Hello everyone, I'm Amir Hossein. Welcome to another training video about the RTTOV model. In this video we talk about how to simulate aerosol affected radiances. I'm in the main directory of the RTTOV model. Go to RTTOV test directory. Here you will find a shell script called run example underscore AER, which stands for aerosol, and file forward.sh. Before running this shell script, I open it. Inside this shell script you can find different variables. Many of these variables are similar to the shell script that we used in the previous video for simulating clear sky radiances. But there is two major differences between this shell script and the previous one, and these two differences are actually two variables that are related to the aerosol. One variable here, aerosol coefficient file name. You should specify the relevant coefficient file name for the satellite sensor that you are using. So you actually have two coefficients file. One coefficient for the normal simulation and the second coefficient file for the aerosols. So the first coefficient file is actually for the atmospheric variables, and the second coefficient would be for the aerosols and particulate matters. And particulate matters can be aerosols can be particulate matters and also gaseous agents. So and there is another variable, which is this variable aerosol profile dat. So for atmospheric variables you need an input data, and also for aerosol variables you also need another input data. Just let me show you these aerosol profile.dat to see how can you find inside this file. Go to the test example .1 directory, and here you can find aerosol profile.dat. You open it. Here you can find the profile of some aerosols. These are actually the names of the aerosols, some standard aerosols. If you want to know about which aerosol exactly they are referring to, you can study documentations. I'm showing the documentations, so here you can find the exact name of each of these aerosols: mineral dust, droplets, volcanic ash, sea salts, and so on. So here you can specify the concentration of each aerosol agent, and this is actually the concentration of each aerosol for the first profile. If you take notice of the number of the profile, this is the first profile, and this is the second profile. Sorry, this was the second profile. The first profile specifying the concentrations of the aerosols for the first profile was actually was not included in this file, and it was specified by number 6. So what does number 6 mean? Number 6 means maritime clean, which it sets an average value for the whole profile, for the whole profiles. So if you don't have certain values, if you don't have exact values for the profiles for each of the, if you don't have exact values for each of the aerosols, you can just set a value which stands for a standard value or average value for all the profiles. So you can just forget about specifying the exact values for each profile. But for the second profile, since we have the exact values, as you can see here, we specified the values, and now it can be used in the simulations. And so we have only two profiles. Profile 3 is empty, so we just have two profiles. And also, if you test the profile, the atmospheric profile, if you test the atmospheric profiles, we also have two profiles here. First profile, pressure levels, temperature levels, and water vapor, and also second profile. So the number of profiles must be equal in both files, for the atmospheric variables and for the aerosol variables. And also the number of these atmospheric pressure levels, the number of these the atmospheric pressure levels should be equal in both of these files. If you count the number of these atmospheric pressure levels, they should be equal in both files. Okay, just now let me run this shell script. You are supposed to specify the Fortran compiler. Okay, I run it, and test was successful. Now in the same directory that we checked, test example, in the text example directory, a new file is created, output example dash aerosol. I open it, and here you can find the calculated brightness temperature in presence of aerosols. So this is actually aerosol affected radiances. You can also test this in another form. You can change the concentrations of the aerosols and see what happens after you simulate for a changed concentration values.